Small signal analysis. Small signals mean the signal has a small amplitude and the transistor operates near the Q point. The AC voltage and current values of the small signal are usually less than 1/10 or 1/10 or 10% of the Q point value. In other words, if the change of AC input signal is very small and enough for the AC output current and voltage changing in the linear region of the output characteristic of transistor, it is said that the transistor is operated in the small signal condition. For the small signal operation, it is assumed that A. The transistor is not operates in the cutoff or saturation region. B. The transistor operates in the active region and the parameters values of transistor such as beta are assumed constant. Small signal circuit analysis has two components. First, DC analysis or DC biasing analysis. Second, AC analysis or small signal operation analysis. DC biasing aims to set the DC operating point of BJT amplifier for input current IB, output current IC, and output voltage VCE, which is known as quiescent point or Q point. The Q point should be placed in the active region and at the center of the AC load line in order to give the optimum biasing operation for the amplifier. In other words, the aim of DC biasing is to place the DC output voltage at the center of AC output voltage swing. The AC input voltage causes the AC output voltage swing above and below the DC biasing voltage level as shown in figure 4.6. This is the DC and AC output voltage of VCE versus T, that is the voltage across terminal collector and emitter of the transistor BJT. This is the AC voltage of VCE and this is the DC voltage of VCEQ. The AC analysis mainly aims to determine the AC voltage AV and current gains AI of the amplifier. Other parameters such as input impedance Zi, output impedance Zo, and frequency response of the amplifier are also of great concern. In other words, the objective of AC analysis is to determine the input impedance Zi, output impedance Zo, open circuit voltage gain AVOC, voltage gain AV, overall voltage gain AVS, current gain AI, overall current gain AIS, low cutoff frequency FL, and high cutoff frequency FH of the amplifier. In our topic, we only focus on input impedance Zi, output impedance Zo, open circuit voltage gain AVOC, voltage gain AV, and overall voltage gain AVS. Small signal equivalent circuit model. When a transistor operates linearly in the active region, it can be replaced with a small signal equivalent circuit model that represents the AC characteristic of the transistor. A model uses the parameters that approximate the behavior of the transistor. The model that can be used to represent a BJT equivalent circuit are Habib-Pai model, RE model, H parameter model, and Y parameter model. Each model has its own specific characteristic that is more suitable for a certain type of analysis as compared to the other models. In this topic, we only focus to a habit pi model. Habit pi model is easy to use and can be easily changed to each parameter using appropriate formula. This model will be used exclusively in this chapter because it is very versatile and can be used at any frequency such as low, middle or high frequency without changing any parameter. Habit pi model. The habit pi equivalent circuit model for BJT at all frequency such as low, middle or high frequency is shown in figure 4.7. This is the transistor of BJT and this one is the habit pi equivalent circuit model for BJTs at all frequencies such as low, middle and high frequencies. However, at mid-frequency or middle frequency, the value of reactant capacitance of internal capacitor such as C pi or CBE, C mu or CBC, and CCE are relatively high due to the capacitors have very low value in the range of picofarad, so that these capacitors are considered as open circuit. These capacitors are open circuit: CBC, CBE, and CCE. This resistor Rx is very low and assumed as short circuit. This is habit pi equivalent circuit model for BJT at mid frequency. So you must remember this circuit in order to do the AC analysis. The value of output resistance RO is typically very high, and in many cases, this resistance is assumed as open circuit. The relationship between the transconductance Gm and current IC is as below. Gm equal to QIC divided by KT, where Q equal electron charge, K equal Boltzmann constant, and T equal room temperature, that is same as 298.16 K. If all the values of Q, K and T are replaced in the formula, so you can get Gm equal IC over Vt equal IC over 26 millivolt, where Vt equal to 26 millivolt, which is thermal equivalent voltage. The unit of Gm is Siemens. The relationship between the transconductance Gm, current gain beta and resistance R pi are as below. Beta equal HFE equal IC over IB. R pi equal VBE over IB equal V pi over IB. And Gm equal IC over VBE equal IC over V pi. Therefore, Gm R pi equal beta, or R pi equal beta over Gm. This formula you must remember to do your AC analysis. Important steps to determine the AC equivalent circuit of BJT amplifier at mid frequency. First, set all the DC supplies to 0 such as the DC supply voltage is short circuit to ground. Second, short circuit all the coupling and bypass capacitor. At mid frequency, the values of the reactant capacitance of the coupling capacitor such as C1 and C2 and the bypass capacitor such as CE are relatively small. and considered as short circuits. Third, open circuit all the internal capacitors of BJT equivalent circuit. At mid-frequency, the values of reactant capacitance of internal capacitors such as CBE, CBC, and CCE are relatively high and considered as open circuit. 4. Replace the transistor with a hybrid pi equivalent circuit model. 5. Draw the AC equivalent circuit of BJT amplifier and commence with the AC analysis. Number 6. If the AC equivalent circuit is complex, the circuit should be rearranged and redrawn so that the AC analysis is easier to perform. Important steps to perform the DC and AC analysis of BJT amplifier circuit at mid-frequency. First, perform the DC analysis to determine the Q point values of BJT amplifiers such as IBQ, ICQ, and VCEQ. During the DC analysis, the AC input voltage is short circuit to ground and the external coupling and bypass capacitor are open circuits. Ensure that the transistor operates in the active region. Second, determine the parameters values of hybrid pi model of BJT equivalent circuit such as transconductance GMs and resistance R-pi. Third, draw the AC equivalent circuit of BJT amplifier and determine the input impedance Zi, output impedance Zo, and open circuit voltage gain AVOC. 4. Determine the voltage gain AV equal VO over VI and overall voltage gain AVS equal VO over VS.